today's lecture. It's my great pleasure and honor to introduce to you Dr. Miljana Radivojević, who will be presenting on the topic, the rise of metallurgy in Eurasia, archaeological science, and the new interpretations. Miljana Radivojević is an associate professor in archaeological science, her PhD in archaeometallurgy. During her previous studies and research posts at the University of Belgrade, Cambridge, and UCL, she has developed a strong research profile in both fieldwork excavations and laboratory analysis of material culture, specifically technology of early metal making. She specialized in the emergence of early copper making in the Balkans before expanding research collaborations across Europe and Northern Eurasia, with emphasis on the Central and Southeast Europe, Anatolia, Central Eurasia, and China. Taking all this into account, there is no doubt that today's lecture is a great opportunity for us to delve into cutting-edge research on the early metallurgy in both our region and neighboring areas. And with that said, I wish you to enjoy it. And now I invite Miljana to take the floor.
Thank you very much, Zorica. It really felt pleasing to sit on this side of the screen and talk to you, a professor in your own right at the Faculty of Philosophy and Learning and Remembering our times together ago 25 years ago. Really, really pleased for the invitation, and obviously I'm very grateful for every soul that came today to listen yet again about the rise of metallurgy, which I thought is the topic that everyone heard, but not really everyone heard about. But I am going to present more than 20 years of work in the field. So thank you to the organizers of ARVA for this really exciting invitation, and I'm really pleased and I'm hoping that you will enjoy it. So let me just share.
I'm sure we will.
Let me just share like this, and just to remove these things that float around. Right, so yes, you see it in presentation mode, right?
Yes. Yes.
Perfect. I just want to remove this floating panel. Height, yes, floating controls. Perfect. Okay, well, yes, that's it. I've been introduced better than I could imagine introducing myself. So I'll just get on with this. So when it comes to talking about the first and the earliest, obviously there's always fascination with the oldest record of something, and it is not always it is academic work, obviously, but it's always nice to be able to say that we've got the oldest this and earliest that. But it is this sort of quest for origins agenda that some of us, or many of us, are pursuing in archaeology, and I have been guilty of that in a way, because when the first evidence for metal smelting was discovered back in 2007, actually, and published in 2010, we ensured that whatever media outlets are there, they know about this research, only because we know that this is how you get attention and create some traction for further research grants, which has got this impact component embedded in it. So questioning these origins of early metallurgy really goes back to learning about the use of minerals, of copper minerals, of green stuff, if you like, in the Near East, in this kind of a fertile crescent. But it's very important to emphasize that copper mineral use and copper smelting are two different operations, because they require different levels of skills. Because when you turn rock into metal, it requires understanding of the temperature and understanding of the pacing of the temperature. And ideally, what we are looking for when we are looking for the early metal smelting in the fields this is how it should ideally look like on the left-hand side. It should be a hole in the ground with a vessel where you have some ores and charcoal on top and some air supply. But you know, the chances of finding something like this are equal to winning a lottery. So we usually deal with a fragment of the crucible or the fragment of the slag, and we try to blow it up into a full story where we can. So the debate about the earliest copper smelting in Eurasia was mostly concentrated about this infamous, if I may call it, Çatalhöyük slag that was reported back in the Melot excavations. It was indeed a piece of slag, but it was non-intentionally smelted, as we have shown in the publication from 2017 after revising the entire set of samples. And then we have the Tali Iblis site where we don't have an exact date because the slags and crucibles that come from this site dated based on relative chronology and come from re-excavation of the spoil heap on the site. So that really is unfortunate, but I'm pretty sure that we can argue early beginnings of metallurgy in Iran around that time, around 5th millennium BC. We were extremely lucky with the site of Belovode, where excavations were taking place at the time when I was taking samples for almost 20 years, 15, 20 years. And it was published in 2010 in Journal of Archaeological Science as part of my early research steps in London, my master's thesis, and then continued well into a fully blown PhD project and postdoc. But it was big news because we have finally the well-dated sequence and a well-explained technological procedure. So rather than arguing who's got the earliest in the world, what I was interested in my research was how distinctive was the knowledge of early metal making in the Balkans versus what was happening in the Near East. And for that, I embarked on studying a various range of materials, such as like ores and slag sherds and slags and metals, some copper, but not some copper. And I'm going to talk about that in a minute. So when we look at the invention in archaeological literature, this is where I'm stopping only for a brief theoretical consideration. We often mix it with innovation. But invention is a complex creative act that underlies technological development of an individual. So it has to be a radically new product. It has to be some radical recombination of technological components in a novel manner, or it has to be an application of an existing technology to a completely new purpose. It cannot be just like a step in the process that is innovative. It has to be something that is like radically changing the concept and the story. So when it comes to simultaneous inventions, another, I would say, very contentious topic in archaeology, it actually is possible when we think about potentially similar social or economical surroundings and environment where societies are evolving. We know that pottery is invented 20,000 years ago in Northern Eurasia. So, before agricultural development and revolution in the Near East. So we can see that in different parts of the world, this linear evolution of society or just one model of the evolution of society really does not apply. So I believe that there is no reason to think that there were no multiple inventions of metallurgy either. But it's another trick of showing that in archaeological record. And yet another theoretical consideration kind of wrapped up in this caricature is that invention is not enough for innovation. So I would imagine, and this is what I'm going to keep coming back at, that the record that we have of the earliest copper smelting is the earliest to us right now, is the earliest documented. But who knows, how many people in the past were throwing minerals in the fire and getting something, but that never took off because there was no demand, there was no understanding, there was no logistics for the adoption and acceptance of such an invention. So something just to leave out there maybe for the discussion. So when an invention affects the evolution of the system and it's successfully transmitted within a population, it is then recognized as an innovation. And I like to show this innovation curve very often. It is used in economy and management studies, this famous S-curve, but also in archaeology, where anything that we know is developing is kind of having these early stages, and it takes off, and now it reaches then the saturation in this kind of upper curve. And what is archaeologically visible is kind of a later in the stage, what we see to be omnipresent. But these very early beginnings, the first and oldest are actually not the first and oldest if you look at the curve. Those are the first that we find. But these very first, the beginning of attempts, are archaeologically invisible. Or I believe that will be like absolutely amazing luck for someone to find it, but we still wouldn't know whether that was the earliest in the world because we haven't dug up the whole earth, if you see what I mean. So invention, therefore, is a process. So we have the stage of gestation, the cradle and maturation, and I nicked this concept from the history of science because we rarely see archaeologists diving into these concepts of invention. But to their credit, this is where archaeomaterial science is very powerful. So gestation is a stage where when creator is creating a capability without knowing the final form. There's lots of experimentation involved, but we don't know what's coming up. The cradle is, again, more playing, more experimentation, but it has some sense of what it could be. And maturation is where the invention has a reasonably mature form and it is no longer dramatically changed. And only this is the place where it is becoming innovation, because this process, which is mature, is being adapted, adopted, and spread across a society or like a larger area that we are talking about. And these processes are rarely taking place in one generation. And I think these little jumps in theoretical considerations are very important when you think about the data that we have at hand and where can we take this debate further. So I came up with this sort of a first help evolutionary model of technological invention innovation in order to make my life easier looking at the data, because I was thinking about how I can connect this invention innovation. And basically the idea was that I look at the process of invention and the process of innovation, and I try to find the secret ingredient, the secret cultural trait, if you like, the technological recipe. In evolutionary archaeology, which I embraced fully during my research, it is called a techne. I know it's a not so catchy phrase, but it can be called a trait. It can be called, again, the recipe. It can be called anything you can think of that actually circulates through all these phases. Because in order to connect invention, innovation of a certain process that you're looking at, materially speaking, or speaking engineering terms, we would need to find a component that flows throughout. So where we are in the Balkans. I'm looking at the period between 6200 and 4500 BC. Why? It's because regardless of the fact that at 5000 BC we had this earliest metal smelting, the way to look at invention as a process is to look at the very first emergence and the use of copper minerals, and that takes place only kind of by the end of the Mesolithic and early Neolithic in the Balkans, which is around 6200 BC. So many of you know and familiar with the site of Lepenski Vir, but I'm just showing it for the wider audience. Then we have around 5500 BC, the emergence of the Vinča culture and these massive tell sites across the Balkans. Then we have these first indications of, if you like, social inequality, where sites like Duran Kulak, where we have the funerals with some prestigious items, but also the site of Varna with kilograms and kilograms of gold at a time when no one else had gold. So it's pretty immense. But what is very exciting about this period is that the material culture is absolutely mesmerizing. The potters are reaching their pinnacle, if you like. We have gold dust applied on the pots, on the big plates. We have these beautifully executed geometrical patterns. We have these outstanding craftsmanship of perfectly symmetrical objects. We have these highly black burnished pottery, almost the shine of a silver, and with added graphite on top to really give this metallic shine, if you like. So when you think about why would metallurgy show up in the Balkans, and look at other pyrotechnologies such as pottery, we can see that there was a lot of experimentation and a lot of mastery applied in pottery technology in particular. So looking at this copper mineral use in metallurgy more specifically, I started with as I said, 6200 BC, early Neolithic sites, Lepenski Vir, Vlasic, and Ahat Kolubara, when I could see two types of minerals being used. One was purely green, used for decoration, and the other one was dark black and green. So there were just lumps of those minerals lying around in Vlasic in particular, also in Lepenski Vir. I could not ascribe any function to them, but what is very interesting is that in Eastern Serbia, which is very, very rich in many different types of copper mineralizations. I'm talking about massive sulfide deposits. I'm talking about polymetallic deposits. I'm talking obviously about native copper, malachite, primary copper ores, secondary copper ores. They choose these societies to go for the green and the black and green. So it's not because it was convenient, it was because there was an idea behind this. So winter culture, as I mentioned, and many of you are very familiar with this phenomenon, lasted from 5400 to 4500 or thereabouts, a little bit later in the south. And I studied the whole assemblage, again, of these beautiful copper green minerals and the black and green minerals or ores, again, showing up in all the records in the winter culture. And these so-called slag heaps, as they call them, but heaps in a sarcastic way, because the whole heap of slags that I had from 3 different sites in Belovo, Devinče, and Gornja Tuzla amount to just under 10 grams. And that was basically the basis of my PhD. And we have a lot of copper implements and something that didn't really look like copper. All of that was analyzed at the UCL laboratories during my PhD, but later also during the postdoctoral years, and continue to be looked at. So the main results are the following. The black and green copper ores that started as mineral picking up at the early Neolithic, across the winter culture sites and across the early Neolithic sites are all the same, macroscopically, microscopically, but also chemically. They have equal amount of copper and manganese. We have actually in Belovode, just before this earliest dated slag sample around 5000 BC, an initial failed attempt to smelt copper. I picked up this mineral without knowing it was attempted, a failed attempt. I was just going for all the minerals I could find in the site of Belovode, and cutting through, I could see that the shiny prills of metal, as you can see on the micrograph, are actually the first attempts to smelt. They did not succeed because I could see it was not thoroughly molten copper metal sample because of this mineral sitting on the edge on the left. But then we have around 5000 BC, these consistent smelting practices across 3 different sites. Although they look messy, these micrographs, they show the heterogeneity of the samples, but basically the same principle of the smelting, while ores were a little bit different in 3 different sites. So what I can tell you is that what they were picking, looking at the chemistry of the slag samples, is that they definitely had these black and green components, these manganese-rich slags embedded in each of these samples. However, other ores included in the process were green and blue and light green and violet and so on. And it is very interesting to emphasize that these minerals that I place on the slide are not all copper-based. Actually, some of them have 0 copper, but they were picked because of their color, such as this violet one, or such as this next to it is a kind of emerald green, is Vivianite. It's like iron phosphate, but it's got a really alluring color. And we can see that at a very early stage, the early metal smelters were actually experimenting quite a lot with aesthetics and the color. And to be honest, and to their credit, they didn't have any fancy machines to figure out what was malachite, what was not malachite. They just went for the green or the blue, thinking that will give them copper. So the rise of Timbro's metallurgy at the same time was also very exciting, because one of the samples from the site of Plochnik, which was very well dated towards the, well, we now believe it's around 4650 BC. That was the latest horizon we could get in the site of Plochnik. It had tin. And that was really a big surprise, because who would expect tin bronze in 1500 years before it occurred in Mesopotamia? But looking at the chemical composition of this Plochnik foil on the left, we actually can see that it's got a very dirty chemical signature. It is not just alloying with copper and tin, it is alloying copper with copper tin bearing ore, because only the complex ore would have this kind of a dirty signature with arsenic and sulfur and iron and cobalt and nickel and so on and so on. So looking at the wider scope of intraculture, there was actually another a sample from Gomolava, a little ring analyzed by Barbara Ottaway, which I then reanalyzed with the generosity of the Museum Vojvodina, that I could see again the similar dirty signature. And it prompted me to look why were they produced? Looking at the micrographs, which are these big images with scales attached to the images of the samples, I could see that this production of the tin bronzes was not haphazard, because on the left-hand side, I can see that this foil, judging by the metallography, were just lightly touched and left to be maybe wrapped around something, while on the right-hand side, the Gomolava sample was literally beaten to death. It was possibly a foil, and it was folded many times until it reached the desired function and desired shape. And I can see that by looking at the size of the grains on the micrograph, and also at these elongated inclusions of which are sulfur rich at the time. It was all published in Antiquity. And another thing that was, I guess, very important about this research is that the only copper tin bearing complex ore that we have in nature is stannite. And indeed, stannite has got copper and iron and zinc and antimony and sulfur. And it looks pretty kind of blue golden, as you can see on the left-hand side, but that's a photo from the mineral collections. And mineral collections are always nice and clean. But if that was in nature, and that is in nature, that was found in nature, because of the atmospheric influences, you can just imagine that the copper component of this ore would have been patinated in green, and the sulfur-rich component of this stannite ore would have been darkish under the atmospheric influences. So we come again to this play of aesthetics, the black and green ore that obviously the people at the time did not know was stannite, but they went for the appeal of the black and green. And the idea is that I have is that obviously they went with the kind of initial choice, but then figured out along the way how to work with it. So why were tin bronzes produced in the 5th millennium BC? Well, they coincide with this Varna emergence of gold. And one of the co-authors of the paper actually gave me the idea to explore this golden aesthetics and the golden preference at the time. So we didn't have before any experimental samples for how copper tin with 11 or 12% of tin, so copper with tin look like. So I went to the Faculty of Technology and Metallurgy in Belgrade, and we set up a research with an undergraduate student back in the days, and we prepared some 60 different metal samples, binary and ternary alloys of copper, copper tin, copper arsenic, and copper tin arsenic to basically cover the entire prehistoric metallurgy production. But we had a goal to see how will tin shine in copper at around 10, 11, 12%. And indeed, we were not wrong. It had a golden color. So the idea that I had at the time with my colleagues is that possibly the appeal of the golden color of these tin bronzes was the reason for the very limited production at the time. I don't know who was imitating who and what was more precious, but they're just out there until we find something more. I have to say that this is not the only tin bronze samples, the two that we have from the Vinča culture. There are 14 others in Bulgaria that I also have reanalyzed, and that also fit with this wider geochemical signature of using stannite or stannite with phallors and copper. So it is something very interesting and intriguing happening in this time, which hasn't got anything to do with producing weapons made of tin bronze. These are all trinkets, all decorative items, which just adds further to the idea that they were used for their color rather than their superior mechanical properties to copper. So looking back at these cycle of invention and innovation and coming back to these theoretical considerations, looking for the techme, what I can tell you from the evidence presented is that this gestation stage of playing and understanding what is going on with the minerals is the stage where we have the experimentation with black and green stuff, basically picking them up from nature. That is enough at this point at the site of Lepenski Vir and Vlasec in Kolubara. The next stage would be cradle. The cradle is the almost there, so but failed attempt. And we have that in Belovode pre-5000 BC. The maturation stage, we've seen that it works across 3 different sites. Then we can see the metallurgy has been adopted because it has been replicated across the space. We have at the 5th millennium BC in the Balkans around 4.7 tons of copper metal from that time preserved in the museum archives. And it equals, I think, to more than 4,000 artifacts that we have preserved from the 5th millennium BC. And then we can see the recombination of the elements, the use of this appeal of the black and green copper ores to produce something completely different. And that is the stage of reinvention. But the element of the trait and the recipe that cuts across all of these stages is the black and green copper ore, is the appeal of this geological, obviously mineral at the time, but it is the black and green that they are obsessed with because they know that the black component does something to clean up the metal. And we know nowadays, chemically speaking, that manganese is more powerful in creating slags than iron, in a way where manganese can form more, around 7 oxides and iron, I think 3 or 4, but it's much stable under unstable conditions. And we can imagine that early furnaces or early smelting installations were not really perfect, were not really meant for industrial scale of production. Just quickly, and I'm not going to go through this in detail, is to show that previous analyses, and I have more to show later, have already indicated that there was the use of local Balkan resources, disappointingly not Rudna because it's got infamously scattered lead isotope signature and radiogenic, so it is not possible to plot anything against it. However, we could narrow it down to the minor Drela, which is near Belovode, to Majdanpek, some of it to Aibunar later in the stage. We also have the groups of materials that have no origins, but they group together. We believe it could be somewhere in Eastern Serbia, given the connectedness of the entire space with Eastern Serbia, but I'm going to talk about that a little bit later with the results from the project. Another thing that I have, I think, rarely spoken about is the early lead. At the time when we were analyzing the copper samples, we also found in the excavation records the lead slag sample. And as much as I tried to fault the record of it or to fault the context of it, I cannot. It was found in the Vincha B2. It's around 5200 BC. There's no intrusion in that range. I've dug the site of Belovode. I understand now the formation of the site. This is 5200 BC, but it is a slag sample which is based on lead. And I'm going to give you just a few ideas about lead. What we know about early lead is that we have these late 6th millennium BC lead bracelets in Iran. We also have the use of lead in Çatalhöyük around mid-7th millennium BC. We have the indication of the lead balls in Vincha Belograde, and I think that was the record of that was very kindly collected by my colleague Dragan Antonovic, about Vasic's excavations and his observations about galena bead found in the vicinity of these shallow pit balls and similar installations used for lead smelting even to, in the early 20th century. So there is something, if you like, if I may call it fishy, about the use of lead. We kind of cannot seem to catch it properly. There is the early Balkan lead just around 4450 in Gornja Tuzla, and then later around 4400s in Pietrele, Romania, that is a confirmed lead production. So that is not an issue. But 5200 BC could be just stretching it a little bit too far. However, as I said, I could not fault the context of it yet. So it's a very heavy one, and it stands in stark contrast to the copper slag sample, which is tiny and barely, sits at the palm of my hand. Looking at the composition and the microstructure, it is a well-developed slag. They have reached the 1200 degrees. There's a residual arsenopyrite, copper metal, matte, I mean, it could be just something that was produced and they never knew what to do with it. I would be happy with it. I'm gonna come with the conclusions, but this is a well-developed slag. And what they were producing, the metal that was produced in this slag was actually lead. And we can see the lead metal still preserved in the slag sample after more than 7,000 years. So two ideas for why is that one, that it was intentional, that there is a scattered evidence from Iran to the Balkans. Maybe we need maybe more research. Well-developed slag may imply some intention by the inventor, if you like. And when I look at the lead isotope of this slag, it is matching on spot the same deposits used for copper extraction. The second hypothesis is that this was completely non-intentional. Because there is no known connection between slag and lead beads in the Balkans that we have from Glumat's excavations and Glumat's analysis of the Vinča culture lead before, and experiment. Maybe that was the experiment that was abandoned at the time. I'm happy with both conclusions. I'm just saying that I cannot fault the context, and it is a very exciting and interesting sample. Given all of this together, the polymetallic, I call this the polymetallic evolution of the 5th millennium BC Balkans, because we have, from the 5th millennium BC, we have, or even earlier, we have copper and lead and gold and tin bronze and some silver lurking from the Aleppo, so from the south, from Greece. So it's very quickly that they reach this, if I may say, experimentation stage within almost 500 years. So this research that we've done, and I speak we all the time because it's a joint research of National Museum of Belgrade and National Museum in Prokuplje, the Homeland Museum, and the Institute of Archaeology, so it's a research of more than 20 years, is that we changed the course of the Rise of Metallurgy and our understanding of how it developed by adding new dates and shifting the focus towards the Balkans as the place where the earlier metallurgy actually developed from the Near East. And I talk about the lead dates, the copper dates, and the tin bronze dates. So we continue investigating all of that within the Rise of Metallurgy in Eurasia project, which was AHRC funded, so by the UK. You see some pictures from the field. We have published the monograph, and I very happily see some of the colleagues who were participating in this monograph making to be online. It was a very successful project with more than, well, I think it's 75 publications that came out of this 3-year project, which I count as a success, but obviously there's, hopefully we may have more in the continuation, the follow-up. It was then supported by the Ministry of Culture and the Embassy of the UK to Serbia. So very high profile project with the National Museum in Belgrade. And we have worked on 4 different sites: Belovode Pločnik, analyzing materials from Gornja Tuzla, but also excavating Jarmovac. In the Jarmovac survey, which I just show briefly, we excavated the site, the shafts in Turak. We were hoping that they were earlier because we found also the hammer stones. We also had indications of the use of the antler tool. I'm showing here Savo, who was our local partner and very helpful and instructive. But the dates go to the early Bronze Age. However, I believe this is the only dated early Bronze Age mine in the Balkans. So I'm very happy that we are finally writing it up after some delays due to various situations that we found ourselves in during the project. I'm just showing some pictures from the project, and it was a very successful one that went on for 2 years in Priboj. In the site of Belovode, we had the RGK team from Frankfurt working on geophysics of Belovode. It's all published in the monograph. I won't dwell in too long. What I can tell you is that when it comes to the organization of a spatial organization, most of the metallurgical activities happen in this very dense area in the south, which we call Acropolis, very pompously, but it seems that they live in these clusters of communities around the site. The site is very well excavated, very well dated. We very proudly presented that in our monograph. Of the features that were interesting, I show you the copper workshop. So we we found another copper workshop. I believe that anywhere you look in Belgrade, you will find a copper workshop. I also know that you may be expecting something very fancy, but this is just a layer of soil which is burnt. And there was a lot of, I don't know, slag sherds and some minerals, which are the green dots. Slags and slag sherds are the red dots. And that's the best you can have as a witness of the earliest metallurgy in the world. So I guess we have to live with it as it is. And then we found lots of slag sherds, but also some installations in the soil, such as like a hole in the ground with a pot bottom, and there was a lot of ash layer around that. It could have been an early smelting operation or an early smelting furnace, if you like. These are the kinds of samples we found, again confirming what was happening in Belgrade and confirming our earlier hypothesis. And these are just another more micrographs, more images of slags to show it's again copper, metal, and the same principle, the same process as we already studied, as I shown in earlier slides. What I can tell you about this early smelting operation is that it was a feature with lots of ash around and it looked like a pot bottom. We reconstructed it during our experimental smelting process. As you can see in this slide, we just tried to build the same feature and to see whether we would have the same debris. And indeed we had, without any slag attached to the bottom of the pot. Why? Is because we put a lot of twigs for burning, for setting up the temperature, and then on them and lots of ashes that we created, we placed the copper ores and then more charcoal and so on. So it basically created an isolation layer. So this is why the slag did not drip on the pot bottom, which is the same situation we have in the field. So we can maybe say that was the smelting installation. Another really great thing about the project and the excavations in Belgrade that we had in 2012 and 2013 is that we managed to reconfirm the early dates. The earliest feature of the earliest copper smelting is dated safely to the 49th century BC. That's as close as you can get to 5000 BC, and basically confirming what we thought about this earlier. The site of Plačnik is another one. It's got a little bit of a different configuration. Yet again, clusters of organized little clusters of houses, if you like. But most of the site is eaten by the river. So the interpretation is again out there for more reinterpretations, if you like, because all data sets, I have to say once again, are published online and freely accessible. With the monograph, because the monograph has got a code in there, the QR codes, so you can scan it and you go directly to the cloud where we placed all this data for any future generations who would like to maybe tell a different story. In the site of Plačnik, we know that it is famous for more than I think 35 or something artifacts, implements of axes and chisels. They are around like a kilogram each, very famous, and there's a whole type called hammer axe of the Plačnik type. The site, again, well excavated, well dated. We have a finer understanding about this organization, at least judging for what we have excavated thus far. And we also have the workshop in the house that we excavated, but it is not production. It is more like a secondary melting workshop. So they were acquiring, judging by the data that I have looked at in terms of the provenance, they were acquiring ores or sorted metal, smelted metal from Belgrade and then remelting it in Plačnik. Again, showing some of the images also of the beads, so similar similar story like in Belgrade, but different type of production. So talking about the reconstruction, and I'm aware of the time, we did experimental design of the early smelting based on laboratory analysis and on the evidence we had from Vinča, which are slag sherds and slags. And we also used some of the chalcolithic evidence from South and Eastern Serbia and South Romania, which are these nozzles, ceramic nozzles, that I believe were used as tips for the blowpipes, just because they looked like that, and I couldn't think of any other purpose. So we tried them, but we tried many other designs. We went for the local sources, So following the analysis that we did in the laboratory, we went to sample some ores from Zdrelo, from Rudna Glava, just in case, from Prauria, from Majdanpek. So that was as original as we could get with the experiments. And then the experiments were very fun because we were sourcing the local clay used for Plochnik pottery. And we know that because of research of Silmi Amikone, who was the PhD student on the project, but also using elderflower trees as the blowpipes because they have soft hearts. So we kind of recreated these tips of the nozzles, also a cylinder just to test some ideas. We made crucibles, we crushed some ceramics. So we went around trying and testing different ideas. These are the designs of installations. Why fragmented ceramics is because the slag sherds looked to be pre-fragmented and then that the slag dropped on them. So the only thing I could think about is that maybe they were lining the hole in the ground and then that's how the process reached them, the slags reached them. But you also have ideas to just have a nothing, just a hole in the ground with nothing, hole in the ground with a pot bottom, with clay and crucible, with a pot bottom and a crucible. So many different combinations, but keeping it as primitive as possible. And it was a really good 2 days, I think. We hired a drummer. I have to say that was the first thing I need to explain, is because we realized that when you are doing the blowing of the process and raising the temperature, you do need a rhythm. Because not everyone has to blow at the same time. In order to pace yourself while you're raising the temperature, everyone needs to come in a rhythm, like 1, 2, 3, 4, 4, 5, 6, 1, 2, and then so on. So we needed the drama. And we produce a lot of slag, I have to say. And disappointingly, if you see in the lower left corner, I say disappointingly because in the field during experiments, we had around 10 PhDs in archaeometallurgy. All of us produce what you see in the left lower corner of the slide, which is like less than a few grams of metal, which shows us and us and you that to know how to smelt a metal, a PhD in archaeometallurgy is not helping you. It is a black art. And it's something that obviously we need to go back and rethink again. But it gave us some ideas of how the process might have gone. And it was very helpful. Because in the aftermath, I could realize that all different installations were performing the same. Whether it was the lined hole in the ground or just a hole in the ground, it was the same. We got metal and we got slag. Which just made me think that these early smelting installations were very ephemeral, and we will definitely never find them because they would just grow with the field over 7,000 years. There's nothing durable about them. And we managed to reproduce everything: the slag sherds, the slags, the copper prills, everything we found in archaeological record, even to the microscopic level. If you see on the left-hand side, looking at the optical microscope, this is experimental slag, and on the right-hand side is the bellow of the slag. So we came pretty close looking at the features microscopically, but I can tell you that we overcooked them because we used a very strong fuel made of hornbeam, and I believe next time we need to use something less calorific. Quick question: did they learn to smell copper from ceramic pyrotechnology? There is a straightforward no. They are related technologies, and I can say no with certainty because we had a whole PhD dedicated to this question. And there is a publication that came out in 2020. So very briefly, analyzing the movement of these slags, I can tell you that everything that I have discussed, all the minerals that exist in the copper and polymetallic deposits in Eastern Serbia largely. Provenance analysis again reconfirmed these ideas that Zdrelo and Majdanpek and Aibunar were exploited, but also some unknown geological sources in Eastern Serbia. And while I'm not, harassing you with much of these graphs, they're all published in the monograph, I want to turn your attention to the trace element analysis. They are pretty exciting to the right-hand side. So to the right-hand side, we have the trace element analysis of ores from Rudna Glava. I could see that it's not a perfect match, but there is something about the vicinity of Rudna Glava, or maybe a source close to Rudna Glava, that could be maybe a better match for some of our samples. Rudna Glava could have been used for pigments, but we don't have an exact match, sadly, although it is a mine that is the earliest dated known mine in the world. Meniri doesn't fit into it, that's Bulgaria. And I'm just showing this cluster on the right-hand side, again, published in the monograph, where you can see that you can also have an indication of the objects clustering together, but you don't have the source. But all these objects are Vinča objects. So I believe it is somewhere in Eastern Serbia. So which deposits were exploited? Majdanpek, Zrelo, Ajbunar, Menirid, not really, some of it. Rudna Glava, not sure, maybe something in vicinity. In these so-called group 16 and cluster 8, as I call them, is because it's just the agglomerations of materials that kind of are clustered together, but we don't have the geological source for it. We took this research further into networks of cooperation, working with physicists, where we tried to plot the trace element analysis of the entire assemblage of the Balkan metallurgy in the Chalcolithic and into the early Bronze Age, and see how they cluster together. The idea is to figure out the provenance, but we got something better. It is published in the Journal of Complex Networks, and we actually came up with a method that is super robust when it comes to actually calculating and indicating the spread of certain cultural sphere, or if you like, cultural groups or cultures, based on the trade and exchange networks. And rather than leaving you with this messy network, I'll actually put this slide. What I can tell you is that all these modules, 3 modules that we got in the while analyzing the trace elements, were made without the information on geography, culture, chronology, and so on. However, when we look at the clusters of colors, that's the module, is the blue and the red and the green. I can tell you that basically the blue cluster is the Vinča culture in this 5000 to 4600 BC. The green cluster is the Karanovo culture. The red cluster is the Bodrokeresto cluster. And these clusters are the clusters of metal objects that were made and traded and exchanged within a certain period, within a certain region. And it appears that we basically came up with this mathematical modeling of archaeological cultures very unintentionally, but that you can use basically this model as a kind of an addition to the ceramic typology model, if you like, to designate this area of cultural spheres or archaeological cultures. But that's something that is developed further, and I could see at least 4 different teams of scholars across the globe taking this approach from when we published it and analyzing rock art or Maori archaeology and so on. So the approach is spreading, and I'm very happy about that. So just quickly about the position of the metalsmiths at the time is that we think that how did this innovation happen? It must have been driven by prestige or high-ranked individuals. Why do I say that? Is because nowhere in the Vinča culture we have the house of the metalsmith that would basically show us that they had any preferential status in the society. Everyone were doing a little bit of metallurgy, which makes it more of a cooperative as a community rather than anyhow hierarchized or structured, if you like, society in a way of the inequality or different sort of social hierarchy. I want to show this because I love this find that Adam Crnobenja discovered in Stubline back in the days. He used to call them Alibaba and 40 Thieves. It's basically a figure of a deity, if you like, or a bigger figure, and the smaller figures. But what is interesting about them is that they have these meticulously modeled clay axes attached to them, attached in a way where there was a hole in the right shoulder. And it only shows, for me, an archetypal story about the Snow White and the dwarfs. Well, maybe this deity was the Mother Gaia, was the goddess of the earth. Who knows? I'm just fantasizing here, but what I want to say is that these clay models are basically exact as the typologically with the axis from the time. So it does speak of the prominent role of metallurgy that artisan witnessed, artisan from Stubline. So when it comes to understanding early metallurgy, we can see that it is the consequence of cultural choices as well as technological choices. There is an evidence of community cooperation, but not just an elite individual smith. It is not spatially nor socially restricted in context. It is very common in everyday life. It is very limited in terms of the use in relative to existing materials and tools. It is not evidently transformative for the Vintra culture society or community because, as we've shown in the monograph, a lot of specialists came together to show that basically the transition was very smooth. It did not make a huge dent in their understanding and their cosmology, if you like. And it was just one aspect of broader material and social cooperation and connectivity in the Balkans. Basically, this is only comprehensible through an interdisciplinary approach. And otherwise, it would just be repeating the old narratives. Metallurgy does not equal social complexity at this stage. So where can we go from here? Looking at this idea of the aesthetics, I can tell you that on this plate, I put all the minerals known before the invention of these more modern materials, more modern metals, so until the invention of iron, that we use to make metals, different types of metals. And if you look at the palette, you have these groups of blue-green, metallic gray, red, yellow. So imagine the transmission of metallurgy included maybe a folklore, maybe a story, maybe a poem where it says like, put two scoops of green and a pinch of black and a pinch of yellow, and that would be the recipe to be transmitted. It is with the colors, or however they were designating the colors. But there's a lot in the aesthetics of the process. Even if we look at the beginning of global metallurgy, even in the heartlands of metallurgy, the 5th, 4th millennium BC, Balkans, Anatolia, Iran, we see that although they start roughly around the 5th millennium BC, the Balkan has the earliest dates, but look at the whole region, they all have different sequence of the metals appearing in archaeological records, which speaks of different preferences. So in the Balkans, we have copper and lead and gold and copper, tin and silver. But in Anatolia, we have copper and then silver and copper arsenic and copper silver and with nickel and gold and then tin bronze and then brass and then iron. So these are the stories and these are the narratives that we could tell to ourselves, is that there are many options of how metallurgy evolves throughout the globe. And there is not one narrative that fits how metallurgy and how this technology develops, which only tells us it is, again, a cultural preference, not just technological. So I invite you, obviously, to read the book if you haven't thus far, or if you haven't written it yourself. Finishing with impact activities, I think, is very important. We have worked very hard, and I mention here my colleague Julka Kuzmanović-Sretković, to build the Archaeopark and to invite children to learn about archaeology and dating methods in archaeology. And I very proudly present in the top two pictures, you see a little child sitting on a red chair and showing with his fingers something on a board. That is my nephew, who was 4 years old when he visited the Archaeopark of Pločnik and the museum. He was so impressed with early metallurgy, and even more so that his auntie was participating in that he asked help from his mother to make a presentation to other 4-year-olds in his kindergarten. And as you can see, they are all engagingly listening. And that really fills my heart with joy, knowing that we can reach wide and far with the results of this research. Finally, thank you for your attention. On this image, we have myself and Ben Roberts, the two people who really pulled their leg to make this monograph happen. Thank you very much again. Oh, thank you, Rania.
Okay, Miljana,